we're starting to talk relations and functions today. So relations are essentially coordinates, and they tell you the x and y. The x corresponds to what's called the domain. The domain is also seen as like your input. It's what you're substituting into the equation. And then when you solve it, you get your y coordinate, which is called a range, or the answer, or some people call it the output. But your x goes into the equation, the function, and then your y comes out of it as your answer. So that's how you can find coordinates when given an equation. So a function is a relation where each domain, each x value, corresponds to one y value. So you can't have a function where they give you the coordinates 2, 4, and 2, -5, because you have a repeat in the inputs. There's no equation where you can put in 2 and get out 2 different answers. That's not possible. So if you have a repeat in the x's and they have different y's, then it is not a function. So one way you can determine that when you're given coordinates is with what's called a mapping diagram. So I'll show you that here on the first one. So you can kind of create two little bubbles. You usually see it as like ovals like this. And you have your domain in the left, you have your range in the right. And you just list all your x values in the domain. So if you look at our coordinates here, we have 0, 1, 1, and 2. So I see 1's in there twice. We only write it once. So 0, 1, and 2 are our only unique domain values. Our range, our y values are 1, 2, 3, and 4. And then you draw arrows with the corresponding parts. So 0 went with 1 went with 2, and 1 also went with 3, and then 2 went with 4. So here's things to look for to determine if it is a function. If everything in the domain just has one arrow coming off of it, you're good. But there's a problem on this one because if you look at 1, it has 2 arrows coming off of it. There's no equation where you can substitute in 1 and come out with 2 different answers. So this is not a function. So again, you can do it with the mapping diagram, but there's an easier way. Just look at the coordinates and see if any of the x values repeat. So look at B. Just look at the x values for now. 0, 1, 2, and 3. It doesn't even matter what the y coordinates are. They could all be the same, and that's fine. As long as all your x's are unique, it's a function. Yes, function. So let's try that. Let's look at the x coordinates first, and then see if we have any repeats. So over here, our x coordinates, we have 0, 1, 2, and 3. They're all different, so yes, it's a function. All right, we got 2 more down here. -2, 2, and 2. Uh-oh, we've got a repeat in the x's. We have a 2 repeat. So let's look at the corresponding y coordinates. Well, this is saying we put 2 into some equation and came out with 2. Okay. But then we put in 2 into that same equation and came out with -2. Oh no, no, that is not a function. It's not possible. Again, functions are equations. Looking at B, we have -5, 0, and 5. All the x's are different, so it automatically can be a function. Cool. Another way to do it is when you graph them, you can do this vertical line test. And the vertical line test says if you could draw a straight up and down line and have it hit more than once in our line that we have, or hit more than one point in one straight vertical line, it's not a function. You can't have a vertical line hit it more than once. So we'll graph them, and we'll see if it passes the test. Much like you will probably do. Pass the test. All right, domain values are our x values. The range is our y values. So if you look at this first box, this is like saying the coordinate -4, -3. So that would be 4 to the left, 3 down. There's our first one. This coordinate would be 2, 0, which is 2 to the right, 0 up. This coordinate would be 2, 3, 2 to the right, 3 up. Here we have 4, 3, 4 to the right, 3 up, and 5, -4. 5 to the right, 4 down. So again, we're looking for, is there any vertical up and down line that would hit more than one point? Here, that's the only point in that vertical line. Here, oh, it's 2 points. That's a problem, not a function. Not a function. Now, a horizontal line is fine. So like these, that wouldn't have been the problem. It's the vertical line that is the problem with functions. So here, I'm not going to write the coordinates anymore. We understand that this is our x coordinate, this is our y coordinate. So -6, -5 is down here, -3, -2, 0, -2, 1, 0, 4, 3, and 5, 7. All of them have their own vertical column. Nothing is stacked up on top of each other. So yes, this is a function. Great. Again, it's a problem if there are two in the same vertical line. -7, 4. Let's just preview here. Look at the x coordinates. -7, -2, -1, -1, 0, 1. Do you see any that repeat? Yeah. These, and they have different y coordinates. So already we know this one is not a function. But let's set them up so that we can do the vertical line test. Okay, -7, 4, -2, 6, -1, -1, -1, 3. There they are. 0, 5, and 1, 5. So these ones are the problem. And if you look to the side, it kind of looks like Millhouse. All right. Look at the x coordinates right here. -5, -4, -3, 0, 1, 2. They're all different, so it's a function. But let's chuck them on there. -5, 4, -4, 4, -3, 4, 0, 0, 1, 4, 2, 4. They all have their own vertical line that only crosses one point. That's all good. That's it. Oh, I lied. Oh, I got excited. We're going to graph. We're going to create our own table, which your blank notes have the table in there. We pick our own x's to put into the equation. We solve them, and that will give us our y coordinate. My recommendation is to typically go with -2, -1, 0, 1, 2. It'll show if there's a curve in the graph most of the time, and also it gives us a nice positive and negative feel for the graph. So your column has like the x's already filled out. Maybe it doesn't, but we're going to put in -2 here for x. Y equals 3 times -2 minus 1. Whatever we get for the answer will be our y coordinate. 3 times -2 is -6, minus 1 is -7. So our x that we chose was -2, and it came out to be -7. So there's our coordinate. So go 2 to the left, 7 down. There's our first coordinate. Now let's try it with -1. Y equals 3 times -1 minus 1. 3 times -1 is -3. Minus 1 is -4. So we have -1 is what we chose. You can choose anything. And it came out to -4. How about that? -1, -4. I'm going to move up Oh, I don't know where I'm going to move yet, but I need to move because I'm in the way. We'll move there for now. Now we'll try putting in 0. Y equals 3 times 0 minus 1. 3 times 0 is 0, minus 1 is negative 1. When you put in 0, you got out negative 1. 0, negative 1 is there. How about when we put in 1 for x? Y equals 3 times 1 minus 1. We get 3 minus 1, which is 2. So when you put in 1, we got out 2. 1, 2. And we have enough to graph it, but let's just choose 2 just to be sure. 3 times 2 minus 1. 3 times 2 is 6, minus 1 is 5. We put in 2, we got out 5. 2, 5, boom. Let's make sure this is a nice, pretty straight line. It is. So we draw our line through our points as best as we can. Wow, the bottom side of that was pretty rough. That's it. So I pretty much always choose -2, -1, 0, 1, 2 because they're easiest to work with. You could choose anything unless there's a fraction. And I think our next one is a fraction. Here we go, 1/2. So I just slapped a fly out of the air. Whoa. When I have a fraction, I like to choose numbers that are multiples of the denominator. Now you can still choose -2, -1, 0, 1, 2. But I want them to be multiples of 2 because then I won't have fractions anymore. So I'm going to actually choose -4, -2, 0, 2, and 4. These are going to be our x coordinates. We're going to substitute these in. So 1/2 times -4 plus 4, 1/2 times -2 plus 4, 1/2 times 0 plus 4, 1/2 times 2 plus 4, and 1/2 times 4 plus 4. So half of -4 is -2 plus 4 is +2. Half of -2 is -1 plus 4 is 3. Half of 0 is 0 plus 4 is 4. Half of 2 is 1 plus 4 is 5. Now you might also be able to notice a pattern. Look at our watch, 2, 3, 4, 5. So this one should be 6. Let's double check. Half of 4 is 2 plus 4 is 6. Great. So we can graph these points now. -4, 2, -2, 3, 0, 4, 2, 5, 4, 6. Now in theory, if we drew this line nice and straight, it would tell us, like, if we were to sub in 6, then we would get out 7. Right? Or if we were to sub in -6, we would end up getting +1. So it gives us all the other possible coordinates, as long as we keep a nice straight line with that. All right, this is the last one. -2/3 x plus 2. Again, I'm going to choose multiples of the denominator. Our denominator is 3. I'm choosing multiples of 3. So I'm going to choose -6, -3, 0, 3, and 6. Again, these are our x coordinates. You can choose any numbers you want. So -2/3 times -6 plus 2. -2/3 times -3 plus 2. -2/3 times 0 plus 2. 2/3 times 3 plus 2. negative 2/3 times 6 plus 2. When I'm doing negative 2/3 of something, first I just divide it by 3 because that would be 1/3, and then I would multiply that by 2. Here I have a negative times negative. 1/3 of 6 is 2, so 2/3 of 6 would be 4 plus 2 is 6. 1/3 of 3 is 1 times 2 is 2 plus 2 is 4. Anything times 0 is 0 plus 2 is 2. Look at our pattern here. It's going 6, 4, 2. So each time it's dropping by 2. So this should be 0. This should be negative 2. But let's double check. Negative 2/3 of 3 is negative 2 plus 2 is 0. Negative 2/3 of 6 is negative 4 plus 2 is negative 2. Cool. So we have negative 6, 6. We have negative 3, 4. We have 0, 2, 3, 0, and 6, negative 2. We draw our line through it. And it goes on forever in both directions. So make sure that you also show that by putting the arrows on the end. That's it for this section, folks.